Hello and welcome back to this course on computer organization. So in the next week, we are actually going to get into the core of part 1, which is to take a C program and actually translate it to the x86 assembly code, right? We are going to generate the assembly code. So in some sense, we are going to perform the job of a compiler, right? This is exactly what a compiler does for us. Remember in the initial lecture I told you that we actually don't even care about the assembly or the architecture of the processor on which the C program is being executed. We just write standard C code, right, that will work across any of these processors, and all you need is a compiler, right, to get you to sort of take this piece of code and make it run on a given processor, right? So before we get into that, core part of the section 1, right, I thought it is important for us to understand this word compile. Okay, we use this word compile quite a bit, right? So you will basically use this compile, a C program. And this word is actually quite a loaded word, okay, because it could mean many things. It could mean different things in a depending on the context that we are actually talking about. And therefore, we are going to look at what this whole compilation means. Okay, we are going to define it very precisely in the context of what we want to do before we jump into the next part or the next week. Okay, so what you basically have is, you have a C program, okay. Now this C program, remember, till now we have been dealing with very, very simple programs, but I'm sure at some point in your life you would have written more complex C programs where the programs span over multiple files, okay. Therefore, this C program itself, okay, is going to be written across files. File 1, okay, and you have, let's say, file 2, and typically, right, which it is true in most cases, each of these files will have a .c version and a .h version, okay. We'll come to these details a little later, but what this, this diagram here means is, I have file 1.c, I have file 1.h, file 2.c and file 2.h, right? And all these files here, these are my real files, okay, and that is what we call a, some sort of a C program eventually, right? So all these files are given to the compiler, okay. Now the Godbolt site that we are using, we basically set the compiler to MSVC, Microsoft Visual C, because we wanted to do inline assembly in a particular way, right? And therefore we used MSVC there. Now in order to illustrate this, I need a terminal and I need to go into the intermediate files and all that stuff, and therefore I am going to use GCC for this particular example, okay. So I am sure all of you have coded something and used GCC at some point in your life, okay. So what we are going to do is, we are going to understand the structure of these files, and we are going to see what happens when we give it to GCC, right, and we'll figure out what's going to happen, right. So if you look at it, what I have done, I have got myself a Linux terminal here, okay, some Linux machine, and GCC is the compiler, right. Of course, GCC is the recognized executable that I'm going to use. So I basically say, let me see what's in this file. When I do just list, I have file 1.c, file 1.h, file 2.c, okay. Now let's look at this file 1.c. So file 1.c seems to be a very, very simple file, right? It seems to have a macro which is defined, macro underscore val 20. Then it has a definition of a function fn1 taking two integers, and then it is returning x into y into macro val. Okay, that's all this function is doing, right? And if you go and look at file1.h, it basically has just a function declaration. So that's the first thing that we note. Okay, so what is in a .h file typically? Okay, a file 1.h or whatever, this has function declarations. Okay, then you have an associated C file. So let's call this file 1. Okay, this is basically the C file, and this is going to have the function definition. Okay, these two are two different things. I am sure you have come across these two terms earlier, but we will understand this much better in this particular discussion. Okay, so what I have in this file 1.h is just a function declaration int fn1 int comma int. Okay, that means it says that there is some function which basically has two function parameters and both of which are integers, right? And it is going to return an integer value. Now if I wanted to change this, right, I would basically say float, int comma float. That means it takes an int, first argument is an integer, second is a floating point argument, and so on, right? But in any case, in this example we are going to restrict ourselves to simple integers, and there is a function declaration of this type in this program somewhere, right? Of course, the associated definition for this is sitting in this file 1.c, and the same function, right, which note that this particular definition matches this function signature in the definition matches the function declaration exactly. Okay, int fn1 comma int x comma int y. In the function declaration, we didn't need the variable names. Okay, we'll come to all this a little later. Why we don't need the variable names and all that stuff, we'll come to a little later. But all the function declaration had to do was to mention that it took two integer arguments, int comma int. Now we are giving those integers a name, int x comma int y, and the function does a very simple job. It is just multiplying x into y, right? And then we are multiplying it by a macro value. Okay, that's all function file 1.c and file 1.h are. Then I have file 2.c. Now this one I have not created a header file very deliberately. Okay, there is only a C file. This is of course starting with hash include stdio.h. Why? Because I have used printf in this. Okay, and here is my function main. Okay, main is the is an important part of any C program. So I'll come to why, what happens if the main is not there a little later, right? And in this one I have simply included file 1.h, right? I have included file 1.h and basically done int main, and then I have initialized the local variables x and y to 20 and 30. There is a local variable z which is going to get assigned a value after depending on what fn1 returns, with x and y as function parameters to it, right? So remember, fn1 just did some x into y into that macro value. Okay, that macro value was something else. I don't remember what it is. We'll come back to it later. Then we are simply displaying x into y equal to z, whatever that value is, right? And we are doing return 0. Okay, so what we are going to do now is we are going to see typically how would you have run this file 1.c and file 2.c. This is what you would have done, right? You would have just simply called GCC, given 2 files to it, right? And you look at this, you have an a.out that got created. And when I run a.out, it is saying 20 into 30 equal to some 12,000. Okay, but of course this is not true mathematically because it's getting multiplied by that macro value, right? So, so what I'll do here, I'll add a very interesting thing to this. I will just say macro val, okay, and file1.c, I'll move this, okay, file1.h, I'm going to move it to this header file. Okay, I'll remove it from this. Oh, so I'll just go back and remove it from the C file. Okay, and instead here what I'll do is I'll do hash include file1.h. That's all. Okay, so now let's see if this thing compiles again. Yeah, a.out. Yeah, so it's basically saying 20 into 30 into macro val equal to some 12,000. Okay, why? Because that macro value is also 20 and it is basically 20 into 20, 400 into 30, which is 12,000. Okay, doesn't matter. That really is not the point of this exercise. Now, when we call GCC and just gave it 2 C files, internally many other things are happening. Okay, and the purpose of this lecture is to understand that much better. Okay, so when you give a C file, right, you give file 1.c, okay, you give it to, the first thing that happens is preprocessor. Okay, there's something called a preprocessor. We'll see what that is now. Likewise, file 2.c goes through another preprocessor, right? So after this you are going to get some intermediate output. Okay, so we'll see what that intermediate output is first. Okay, so what I'm going to do is I'm going to take only the first file, file1.c, okay, where I've done hash include file1.h, and I have a compiler, you know, I have a function definition for fn1 here. Okay, and remember file1.h is here, hash define macro and then the function declaration, and then you stop. Okay, so what I'm going to do is I'm going to do GCC minus capital E. Okay, file1.c. This is actually the intermediate output of the first preprocessor step. Okay, first preprocessor step alone we are doing with this minus E option. So we are not going ahead and compiling or doing anything more. Okay, and what does it do? It basically puts out a couple of lines of the C code. Okay, look at this. It's basically saying some file1.c, some built-in, you know, something. But you recognize all these lines here. Okay, this is exactly the function declaration as it was in file1.h, and then we have the function definition. Okay, so if you look at what this file1.h basically had, it had this. So let's look at the C file. We are doing hash include file1.h. What does this hash include do? It just takes file1.h and dumps whatever text is there in file1.h out at that point in the file. Okay. Now what it additionally does is, so what is in file1.h? Actually it is basically, let me open that file1.h on the right hand side here. Okay, file1.h. Yeah, sorry. So on the left is file1.h, on the right is the file1.c. So when you on the right hand side, when you do hash include file1.h, all that happens is the contents of this file just get pasted here. Okay. Sorry. Yeah, sorry. This. So this hash include file1.h is replaced by the contents of that file1.h exactly as shown here. Okay. Now what it sees is there is a macro val, okay, which says 20. What does that macro do? It simply will do a find and replace. Okay. So all it will do is it will go find these values here, right, and replace it by whatever value is given here. That's why the intermediate file that you see looked something like this. Okay. So I am going to not save all this. I'll just come out. I'll show you the contents of the file after we ran that -e option. It just put out int fn1 int comma int, the function declaration. This anything that starts with a hash we are going to leave out. Basically that's sort of a comment. Okay. Then it basically has int fn1 int x comma int y, and then that macro val got replaced by 20. So this is all the preprocessor does for you. First it replaces all the hash includes, as you know, whatever the content in the header file will come and sit in that C file there, and all the hash defines will get processed by find and replace appropriately. Okay. So all the macro, all that the macro definition does is literally a find and replace, except inside strings. Okay. So let me clarify that for you. So what I'll do is, now instead of gcc minus, I'll do file2.c. You see this, file2.c. What is file2.c, by the way? It is again including hash include stdio.h. So whatever is in stdio.h file. Now where is that file? That is sitting somewhere in the operating system, some path it is there, and that is known to it through the path variable. Okay, there is a path variable, environment variable, that tells it to go look for header files in that folder, some folder, and it finds the header file there. It takes the contents of that header file, replaces it here. Okay, and file1.h, again, what is file1.h? We just saw the function declaration and that macro, right? It will get replaced. The hash define macro val underscore 20, right? So let me just show you that again. Again on the left is file1.h. So again, sorry, these two lines will get replaced here, right? This file1.h, sorry, this file1 hash include file1.h will go, and this would, and of course stdio.h would have got replaced with the contents, right? And then hash define macro val is going to get processed. So it will find and replace all the macro val except this guy, except the value that is sitting inside a constant string. So if you do printf, right, or you define a constant string and put this macro val there, it will not get replaced in those quotes alone. Okay, it will get replaced in all other places. Therefore this macro val here will not get replaced by the value of 20. It will come out as text macro underscore val. Okay, so now I'm going to quit this, right? So if you look at gcc minus e file2.c, right, you will see, of course, the just like the earlier case, int main whatever, see the macro val doesn't get replaced, right? Then the function declaration has come here. This is what is in file 1.h, okay, and then there is like huge amount of data that is dumped from where? stdio.h. Okay, so all that content is coming and sitting here. Remember, keep this in mind. That's what the preprocessor step is in this file, in this compilation process, right? Now that output is what is fed to the compiler, right? So remember, these macros are very, very useful design practices, because when you want to deal with a constant and not a variable, right? See, these variables, right? If you look at file1.c, here there are two function parameters x and y and one macro val. So this macro val is like a constant. Now when you are using such constants, it's always a good design practice to use macros, because they will get replaced during the compilation process, and you can go ahead and define the macro value in exactly one location here like this. So you can use this macro underscore val as a constant everywhere. So what I'm trying to say is, by using this macro val as a variable, we would have used memory, we would have used so many other complicated things. But by using it as a macro, it is getting replaced by that exact macro value by the preprocessor before sending it to the compiler. So it is as if you generated 10 files, each of them, using just the name macro underscore val, but internally they have got replaced before going to the actual compiler. Okay, and that's why it's a very powerful thing. So if you want to change macro val, you come here and change it to 30. Then it will go and reflect in all the 10 files where you have used this macro name. Okay, so that's the key advantage of macros.